first step in finding the inverse of a matrix is to augment that matrix with a suitably sized identity matrix. So since we have a 2 by 2 matrix here, we're going to augment it with a 2 by 2 identity matrix, 1 0 0 1. Now what we want to do is turn the original matrix into an identity matrix using row operations. So our first step is to multiply the first row by 1/3. That doesn't do anything to the second row, so we can write it down unchanged. And then our first row becomes 3 times 1/3 is 1, 5 times 1/3 is 5/3, 1 times 1/3 is 1/3, 0 times 1/3 is 0. Now we want to use that 1 that we just got in the upper left hand corner to eliminate the 2 in the second row. So we're going to say that row 2 is going to be row 2 minus 2 times row 1. So that does not change row 1 at all, so we write it down unchanged. And then 2 minus 2 times 1 is 0, 4 minus 2 times 5/3 is 12/3 minus 10/3, that's 2/3. And 0 minus 2 times 1/3 is negative 2/3, and 1 minus 2 times 0 is still 1. Okay, now we have a 0 in the lower left corner. Okay, now we need to get a 1 in the second position in the second row, so we're going to multiply the second row by 3/2. That will turn the first 2/3 into a 1. So again, nothing's happening to the first row, so we can write it down unchanged. And then 3/2 times 0 is 0, 3/2 times 2/3 is 1, that was the whole point. 3/2 times negative 2/3 is negative 1. And then 3/2 times 1 is 3/2. Now we want to use that 1 that we got in the second position in the second row to eliminate the 5/3 above it in the first row. So we're going to say row 1 is row 1 minus 5/3 times row 2. This does not change row 2. So we'll be able to write row 2 down unchanged. And 1 minus 5/3 of 0 is 1. 5/3 minus 5/3 of 1 is 0. 1/3 minus 5/3 times negative 1 is plus 5/3, which gives us 2. And 0 minus 5/3 times 3/2 is negative 5/2. So we now have our inverse matrix. Since we turned the original matrix into the identity matrix, then what's left to the right of it there is the inverse of the original matrix. Now we can use this to solve a system of equations, provided the system of equations has the same matrix of coefficients as our original matrix that we found the inverse of. And so the solution is going to be that inverse matrix that we just found times the matrix of coefficients of the system of equations, the 6 and the negative 1, which is 2 rows by 1 column. It's a 2 by 1 matrix. So we have the product of a 2 by 2 matrix, our inverse matrix, and a 2 by 1 matrix. So our product will be a 2 by 1 matrix. And we'll get it by doing the dot product of the first row in the first matrix times the column in the second matrix. So we'll have 2 times 6 plus negative 5 times negative 1, which is negative 5/2 times negative 1, which is 5/2. So we have 12 plus 5/2, that's 24 halves plus 5 halves is 29 halves. Then we do the dot product of the second row in the first matrix times our column in the second one, and we get negative 1 times 6 plus 3 halves times negative 1. So they're both negative. We have negative 6, which is negative 12 halves, and minus 3 halves, which is negative 15 halves. And just rewriting that so it's clear that it's a 2 by 1 matrix, we're going to have 29 halves and negative 15 halves. So that gives us our x and y values of our solution. X is 29 halves. That's my dog shaking in the background. 29 halves for x, and for y, negative 15 halves. And we're done.